Now we're going to show you some examples on how to do operations with complex numbers. So first of all, we need to understand that standard form typically has a real number plus an I value. Something like 6 plus 2I would be an example of a complex number in standard form. It has the real number out front and then the imaginary number second, with or without a coefficient. Okay, so that's the standard form we're looking for here. So this is like algebra. Remember that we're treating I like a variable, remembering, of course, that I is the square root of -1. And so we will treat this just like any x or y or a or b in previous polynomial simplification. Okay, so we're just going to follow the rules of algebra. So here I'm just going to rewrite this 2 minus 6i and then distribute this minus sign. A minus and a minus for the 10 makes it a plus 10. The minus and the plus for the 4i makes it a minus 4i. Then I just group like terms. Okay, 2 plus 10, it looks like it's going to be 12, so I've taken care of those two, and I mark them just to make sure I took care of them. Minus 6i minus 4i is minus 10i, just like minus 6x minus 4x would give you a minus 10x for that one. So that actually is my answer. If you wanted to factor out a 2, I suppose you could. You could write 2 as 6 minus 5i. That also is true, but remember, standard form says the real number and the imaginary number are out front. So there's your final answer. Okay, that's one example using addition. Now let's do one using multiplication here. Okay, remember what the video said there. We talked about FOIL this just like you would FOIL 2 plus x, 6 minus x. We're treating I like a variable. So first I'm going to do the first terms. 2 times 6 is a 12. Okay, outside terms, 2 times a minus I is a minus 2I. All right, and then I times 6 is going to be, that'd be the inside terms. Okay, would be a plus 6I. Okay, you can see these two are going to group together. All right, and then minus I times a plus I gives you a minus I squared. All right, so let's talk about this now. Okay, 12, there's nothing I can group with 12 really at the time, but minus 2I plus 6I is going to give me a plus 4I, because the plus 6 minus 2 yields me a coefficient of plus 4. Now let's talk about I squared. If I is the square root of -1 and then I square it, whenever I square anything, it just comes out from under the radical. So I squared really is -1. We have to remember that. Okay, so if minus I squared is -1, I'm simply going to write a minus 1. Don't forget this minus is independent of the I squared. If I squared is -1, I plug it in right there. That's what I'm going to get. So it's actually 12 plus 4I minus a minus 1 is a plus 1. So what this yields to here is 12 plus 1 is a 13 plus 4I. And there is my complex number in standard form. Real numbers first, imaginary component is second, and there you go. 13 plus 4i is my final answer for that one. We'll do some division as well, and division is a little bit more complicated because standard form dictates we get this 1 minus I out from underneath the radical. And the trick to doing that is, let's rewrite it first of all, 2I on top, 1 minus I on the bottom, is we would multiply top and bottom by 1 plus I. There's a reason for this, okay? So whenever I have this factor here, 1 plus I divided by 1 plus I, the equivalent value of this is 1. Anything over itself, whether it's x over x or x squared over x squared or 6 over 6, I can do this because anything over itself is 1. So I'm multiplying the expression here by this thing, which is just going to convert things for me. Here's why we do it, okay, is that we know that whenever we have, say, x minus 1 times x plus 1, when I have two things here, well, if I FOIL this out, the minus x is going to cancel the plus x. I'm going to be left with the square of the first thing minus the square of the second thing. Okay, so 1 squared is 1. So this is what I'm going to get. The reason we do this here is it's going to cancel the I terms. Watch this. Okay, 1 times 1 is going to give me 1. I'm going to get a minus I. I'm going to get a plus I from this. Okay, and so the i's are going to cancel. Minus 1 times a plus 1 here, I'm sorry, this and this, okay, are going to give me a 1. And what am I missing here? It's going to be 1 squared. Okay, I've already got that. Oh, I'm sorry, the last term is what I'm missing. Minus I times plus I gives me a minus I squared. So that's my bottom of my fraction. Okay, up top, I'm going to get 2I times 1 and 2I times I, which is plus 2i squared. Okay, so watch what happens here. Okay, notice the bottom is 1. These two i's canceled. 1 minus I squared is what I have on the bottom. On top, I have a 2. I can factor it out. I'm going to get an I plus an I squared. Just follow along for a second here, okay? All right, and what this means is, remember that I squared is minus 1. So what I have down here is I have a 1 minus a minus 1 on the bottom. Well, 1 minus minus 1 is 1 plus 1, which is 2. Okay, so up here now I'm going to have 1 plus I squared, and we know I squared is minus 1. Let's just scroll up to be sure of that, right? I squared is minus 1. So whenever I see an I squared, which I do here, I'm going to have 2 times I plus minus 1. Actually, I should just write that as 1 minus a minus 1. And I blew it again, okay? I minus 1 is what that's going to be. So the top is going to be 2i minus 2 when I distribute it, and on the bottom I have 2. So when I simplify that, the 2 cancels into each of those, okay, and I'm going to get I minus 1, or if they want it really in standard form, you should write the imaginary number first. Minus 1 plus I is what I'm finally going to get for my final answer. So this one maybe, and I'll write it more clearly here, but you had to follow that. That one is a little bit more difficult, and this is just an expression, so we'll leave the equal sign out. But that's how I simplify complex numbers when they are being divided like they were here. Okay, so that last one might seem a little bit tricky, but if your algebra skills are good, you should be able to see that's your standard form simplification of this problem right here.